y equals sine of ln x here, a neat looking function, and q is the maximum, and we're asked to show that the point P10 lies on C. So let's just substitute x equals 1 in. It's going to be sine of ln 1, which is sine of 0, which is 0. Next up, we're asked to find the coordinates of the point Q, because we can see that I can already see there's a line going from P to Q. We're going to need the shaded area, so that's going to be some integration. So first of all, we need what Q is. Well, this is a stationary point. It's going to be the maximum, so we can differentiate sine of ln x. And if we do that, we're going to get cos of ln x. And then we need to times that by ln x differentiated, which is 1 over x. So I've used the chain rule. And this equals 0 for stationary points. Okay, that's going to imply, well, x is bigger or equal to 1, so we can basically, we can cancel that out. So it's just going to be that cos of ln x is equal to 0. And therefore ln x is going to equal pi over 2, because it's going to be the, you can see it's the first solution. Therefore x is equal to e to the pi over 2. I've just realized I need to then find out what y is. So y is going to be sine of ln e to the pi over 2. The ln and the e just cancel, so it's going to be sine pi over 2, which is then just 1. So that means that q has coordinates e to pi over 2 and 1. Okay, not too bad so far. Now, here's the main bit. Let's find the area of the shaded region between C and the line PQ. So that shaded region is going to be the integral from 1 to e to the pi over 2 of our original function minus this green area here, which is just a triangle, the height of which is 1, and the width is going to be e to the pi over 2 minus 1. So it's just going to be a half base times height. We're going to minus a half e to the pi over 2 minus 1. So let's just focus on the integral. And maybe we'll do the limits in a bit. The main bit is going to be just to try and figure out how to deal with this. We have a function inside a function. It's likely to be some sort of substitution, I think. So like we're not going to integrate by parts. It's not a function, We did differentiate this, but when you differentiate, you get something that's equally as horrible. So I'm going to try and let u equal ln x, because then we'll get sine of u. And du by dx is 1 over x. So this becomes the integral of sine u dx by du du. Okay, dx by du is then just x, which is then equal to e to the u. Okay, this is better, believe it or not, because I've got rid of a function within a function. I've now got a function times by a function, albeit an exponential and a trig one. You might have seen this kind of integral before, especially if you've been doing a few of these AEA papers. We can deal with this. So they're the same. Okay, I've not dealt with the limits, remember. We can worry about that in a bit, I think. So this is going to be, right, this, I know I've got a u. I kind of regret using u now. Let's change it, to be fair. Let's call it t. Because now we can do integration by parts. I'm going to let this be u and this be v dash. U dash is then e to the t, and v is going to be minus cos t. So we get uv minus the integral of u dash v. Okay, double negative, this becomes a plus. Now we've got the integral of e to the t cos t. So same again, this is going to be u, this is now going to be v dash. So I'm going to carry on this through, minus e to the t cos t plus, and then it's going to be uv, so it's e to the t sine t plus the integral e to the t times sine t. I don't know why I'm doing plus there, it should be a minus. And that is great news because we've just shown that this is equal to this, and this is the same integral as here. So we can just add it to both sides, get two of them, and divide by 2. Such a good integral, this one. Factorize out the e to the t, so it's going to be sine t minus cos t. Technically, there's a constant in there as well, but we're not going to be worrying about that. Right, now I'm going to worry about the limits. So I'm back to working out this integral. E, so it's 1 to e to pi over 2. Sort of just need to bring it together and explain what I'm doing. Remember, we did this substitution. T was equal to ln x. Sorry, should have an x here. So when x equals 1, t is going to be ln 1, which is 0. When x is equal to e to the pi over 2, t is going to be ln of that, which is pi over 2. So the limits are 0 to pi over 2, and we're going to have e to the t times sine t. Which we figured out here. So it's going to be a half e to the t sine t minus cos t, evaluated between 0 and pi over 2. And when I substitute pi over 2 in, I get 0 here, I get 1 here, so that's my first term. And I'm going to minus a half e to the 0, and then it's going to be minus 1. So it's a half e to the pi over 2 plus 1. Okay, don't forget, it's very easy to forget what we're actually doing. We are trying to find the shaded area, and I haven't actually found it because I've actually found this whole area, so I now need to subtract that triangle, which is this bit here. Okay, I'm actually going to get rid of that factorized bit. These cancel. We've just got a half plus a half, and the answer, and that is pretty cool. It's got to be said, the answer is just 1. I like it a lot.